Welcome to a new video. This is Mo from APC Mastery Path, and I'm glad to be your guide in today's video. We're going to be shedding the light on how you can fine-tune multiple large language models using Unsloth technique, and then deploying these models to OpenWebUI to act as a chatbot, and then finally compare and contrast between the performance of these models to know what suits best our use case. This video is going to be broken down into a number of parts. The first part is going to be providing an overview about Unsloth, the basic requirements in your system, and then we're going to be jumping towards the fine-tuning technique itself, what you should do, what you should be aware of, and then we're going to be deploying the fine-tuning models on OpenWebUI, and lastly we're going to be comparing and contrasting the models to know what suits best our use case. And now, without further ado, let's get started. In the first part of this video, we're going to be exploring what Unsloth enables you to do, what are the key requirements before we crack on with the fine-tuning, and what are the key pieces of software that we need to have in place. Unsloth method allows you to fine-tune large language models using much less video memory, and it expedites the fine-tuning process. So the technique that we're going to be using today is creating a custom dataset using lots of PDFs compiled into a CSV file, and then we're going to be feeding that data into a large language model of our choice from the wide variety of them large language model available on the Unsloth library on the Hugging Face website, and then we're going to be carrying out the fine-tuning using the Unsloth technique, and finally we're going to be deploying the fine-tuned model to a front-end chatbot using OpenWebUI. After the deployment to OpenWebUI, we're going to be comparing and contrasting the performance of the fine-tuned large language models. As discussed before, Unsloth allows you to fine-tune a number of the large language models using much less graphical processing unit, and it also allows for higher precision and higher accuracy on consumer-grade GPUs. There are some requirements before we dive deeper into that system or that technique. The first one is having a Linux-based system, because unfortunately Unsloth, it doesn't work directly on Windows or Mac. It needs a Linux-based system. There are two ways to do that. It's either you download Windows Subsystem for Linux if you're using a Windows system, and the way to do that is super easy. Just go to your terminal or command prompt on Windows, and then you can type in wsl-install, and then give it some time to download and install Windows Subsystem for Linux. The default version is going to be version 2 for Windows Subsystem for Linux. The other way around it is download Linux on your PC or Mac on a separate drive of its own. The distribution that I use is called Pop! OS from the team System 76, and it's based on Ubuntu. I'll put in the description of this video the link to an article which details how you can download and install Pop! OS on your Windows PC, taking into account the distribution itself, the system requirements, and the installation procedures. Having installed whether Windows System for Linux or Linux distribution, you need an integrated development environment. My integrated development environment of choice is VS Code. You can go to www.code.visualstudio.com/download, and then you can download the Ubuntu version if you're using a Linux distribution, or Windows version if you're using Windows. If you're using VS Code in Windows, on the bottom left you'll find that there is open a remote window, and then you will find one of them choices to connect to a Linux based distribution. But in here, because I'm using Linux already, so it doesn't give me that choice. Having installed Linux or Windows Subsystem for Linux and VS Code, you also need to have Docker Desktop. So Docker Desktop, it allows to have multiple containers running codes in containers, and they are isolated from one another. So the way to do that on Windows is quite simple and straightforward. You just need to go to docs.docker.com/desktop/install/windows-install/, and then you can click easily on your version, whether you're using the Windows for ARM or the x86 version for Windows. You click download, install, and it is quite straightforward. In Linux, it's not quite straightforward. You need to go to docs.docker.com/engine/install/ubuntu, and then you need to first of all uninstall any conflicting packages by copying and pasting that line of code into your terminal, and then you copy and paste it, and it's going to be deleting any sort of packages if you have them installed. Once you have done that, you can then copy that line of code, which is installed using the apt repository. You copy that whole thing and then you paste it in the terminal as well. Once that is finished, you also install the latest version of Docker using that line of code. And finally, you can make sure that Docker is running correctly on your machine by that line of code. It's a bit of work more than Windows, but it's going to take you most probably 10-15 minutes. Having installed a distribution or an operating system where we can actually work, an integrated development environment such as VS Code or Python and Docker, which we're going to be using later on when we're deploying in OpenWebUI, we need an actual programming language, and definitely the one which is of choice is Python. For Windows, it's going to be straightforward. You're just going to go to www.python.org/downloads, download whatever version you would please, and then it's going to be downloaded as an exe file where you can deploy it easily and install it, follow the instruction. On Linux, it's going to be a bit of work, but not too much work, so you have to check whatever version that is installed on your Linux. Sometimes it comes with a pre-installed version of Python, sometimes it doesn't. So you can check the version that you have by typing in Python 3 -- version. If you have a version already installed, then happy days, you don't need to install anything. If not, then you can copy and paste these two lines of code, sudo apt -get update, and it's gonna prompt you to enter the password. You can install it by sudo apt -get update, and then it's going to prompt you to enter the password. Okay, everything is updating now. It's taking a bit of time, and done. And then you can download whatever version you would please. 3.6 is just the version. I would suggest that you download at least 3.10. And once you have done that, it's going to take a bit of time to download Python. Having installed the operating system or the distribution where we're going to work, the integrated development environment, Docker desktop, and the programming language, which is Python, it's now time to install Anaconda for the sake of Conda, because we're going to be using it later on with OpenWebUI and the Unsloth libraries. So in order to install Anaconda, it's quite straightforward. You just need to follow the link that I'm going to be providing in the description below. It's going to download the Anaconda version for Linux. When you save Anaconda, make sure to open terminal in this location, and you just need to type in these two lines of code. Make sure that you replace the word version by 2024.2-1. That was my version of choice when I first started this journey, but definitely there's going to be future versions, so replace the word version by the version of your choice. The last piece of the puzzle before we crack on with Unsloth is installation of PyTorch and NVIDIA CUDA toolkit. They are quite relevant if you have a GPU. So the way to install PyTorch is by following this code, which I'm going to be putting in the description below. And in order to install the NVIDIA CUDA toolkit, you can follow this link, which I'm going to be putting in the description below. Once you open it, it's going to give you a number of the choices, which you can download accordingly. In our case, it's a Linux-based system. My architecture is x86. Distribution, if you're using Windows Subsystem for Linux, you're going to be clicking on Windows Subsystem -Ubuntu. If you're using Ubuntu, you're just going to be clicking on Ubuntu, and then you're going to be choosing your version, whether it's 22.4, 20, or 18. In my case, it's 20.04, and it's Debian local, and then it's going to be copying these lines of code and putting them in the terminal. And it's the same for Windows Subsystem for Linux as well. As you see here, you just click on that one, copy and paste it in terminal, and then press enter, and then it's going to install NVIDIA CUDA toolkit, or as they call it, NVIDIA CC, NVIDIA CUDA compiler for you. And now we have finished the majority of the things that need to be installed, and the last piece of the puzzle is the installation of the actual Unsloth library. That one is pretty straightforward. You can go to the Unsloth repository on GitHub, which I'm going to be putting the link for in the description below, and then just scroll down to the installation procedures, and then you can copy and paste that. For me, I copied and pasted it line by line because the backslash didn't work in my terminal for some reason. So as you can see here, it's conda create and then the name of the environment. In this case, it was Unsloth _env. What Python version? You're free to use whatever version you want. In my case, I just follow that one. And then for PyTorch-CUDA, I used the 12.1. So instead of 11.8 / whatever it is, I used the 12.1. And then make sure that you have these packages as well installed. So PyTorch, CUDA Toolkit, Xformers, PyTorch, NVIDIA, and Xformers. And then you're going to be activating the Unsloth env, which we can do here. So you can go to terminal and then new terminal. Once you have created the environment, conda create whatever it is, it's now time to conda activate and then Unsloth env, and it's going to activate your environment, and then you can install inside of it the remaining packages, that one. So inside of it you can just copy and paste that one, so people install the actual package Unsloth, and then some other packages such as weights and biases, Hugging Face Hub, parameter efficient fine-tuning, accelerate bits and biases, and dataset. Once you have all of that installed, then I'm happy to tell you that the environment installation is now complete. The fine-tuning process using Unsloth is quite straightforward. The code is systemized, and there's no need to spend a lot of time posing the video and writing the code itself. You can go to the Unsloth GitHub repository. There is a wide variety of them Google Collaboratory notebooks that are available for download and deployment. So let's take, for example, Llama 3.1, 8 billion parameter models. You can click on Start for free, and then it's going to take you to the Google Collaboratory notebook, which you can easily download locally on your machine as a Jupyter notebook, and it's going to be straightforward to follow. They have provided all the explanation. I'm going to be shedding the light on some bits and pieces in my code which I found useful for me. Having finished all of them environment dependencies required for this project, it's now time to go and do the fine-tuning itself. So the first step here is importing the necessary packages, including Torch, supervised trainer, the training arguments from transformers, and the datasets, which we're going to be needing when we load in our dataset. And then we need to import the Unsloth library and then fast language model from the Unsloth library and 14.16, depending on what you need. In my case, I used a wide variety of the models. I've used Mistral, I've used Llama 3.1 and Llama 3 Instruct. And now, as you can see here, it's Gemma 2 9 billion parameter model with bits and bytes, 4-bit. You can access all of the models of Unsloth through going to the Hugging Face website, huggingface.co/Unsloth. If you click on that one, you will find a plethora of the models, as you can see here. So they have 121 models available to download and play around with. It's going to take a bit of time depending on your internet speed. The majority of the models are in the range of 8 to 16 gigabytes of storage. The next step is going to be importing the dataset. So in order to give you a rough idea about the dataset that I do possess, it's RICS APC submissions, and it has 3 columns: ID column, question column, and answer column. So give me a good quality example of whatever competency and then the answer of it. So there has to be some sort of a chat template for this data. So the first thing that I've done is importing the dataset itself, and then I've specified an encoding method because I had lots of errors because of the characters from the CSV file, and then a chat template which is going to be an instruction based on the question and providing an answer. The Unsloth team, they have advised to have the question and answer compiled together into one-liner. So that's what I've done here. So create a formatting prompt function which takes in the question and answer, and we have an array called text, and then in each and every question and answer provided, just compile them together and continue appending in this array, and then do that for everything that is existing in the dataset itself. And what I've done here is basically deleting any column that is not text. In my case here, as you remember, it was ID, so just removing that column. Sometimes it's metadata, which might be necessary or might not be necessary in your case. This step here is optional if you want to understand what is the performance of the model pre-fine-tuning. In my case, the performance of the model pre-fine-tuning was so bad, so it needs fine-tuning. I was asking a very simplistic example, help me write a good example of procurement and tendering level 2, and it began faffing about. Didn't provide any answer, as you could see here. The next step would be loading the low rank adapters. So instead of fine-tuning the whole 8 billion parameters of the model, you would fine-tune some of them parameters, maybe in the millions. I think for Gemma 2 it was about 54 million parameters that are fine-tuned instead of the 9 billion parameters. So the documentation for everything related to that, you can find it thoroughly in the Unsloth documentation. The main thing that I focused on is the rank. You can manipulate the rank depending on your data and depending on your GPU as well that is available. The sequence length, we have defined it up top, which is basically how many tokens and how lengthy the text is going to be. And the gradient checkpointing, I think it's advisable to put it as Unsloth for very long context. And now it's time to declare some training arguments before undertaking the final step of fine-tuning. So before we do that, you have to have a key from weights and biases. So in order to do that, you can go to the weightsandbiases.ai website /home and then create an account. It's going to provide you with the API key, which allows you to connect to weights and biases. It was free, but I think for commercial purposes it might not be free. So I've used weightsandbiases.login and then the key itself, and then here I've specified some of the arguments that are required for the actual training. What is the name of the model, which we have downloaded? In this case, it was the Gemma 2 9 billion parameter model, bits and bytes for bit. The dataset name, which is dataset, and then the train section of the data. What is the identifier itself of the data? In our case, it's text because we have compiled the questions and answers in the text. What is the maximum sequence length? What is the tokenizer? Tokenizer is taken from the model itself, and then a whole lot of other training arguments as provided in the transformers documentation and bits and bytes documentation, also Unsloth documentation. There are some of them that I focused on. The warm-up steps. Imagine that you are running in a track and you want to warm up first before you run full speed. What are the maximum steps? For commercialization purposes, I think that has to exceed 1000, but because that is a prototype, I want to explore the art of the possible, so I've just made it as 500 steps. A learning rate, the more you decrease it, the more memory it's going to take, so I've kept it as default for the time being by 10 to the power of -4. And then Adam optimizer, that's the most famous optimizer nowadays. It's now time to train. So just train to train, and then it's going to take you a bit of time. In my case, it just took me about half an hour, but I do possess an RTX 3090. Definitely, if you have much better GPUs, you're going to take less time. As you can see here, the number of trainable parameters using the LoRa technique, it's 54 million instead of 9 billion parameters. Having finished the training of your model, it's now time to save the model itself, or whether you want to just save the LoRa, depends on what you need. You can save the LoRa only by using the model.save_pretrained, then you can specify the folder where you want to save, and also you can save the tokenizer if you want to deploy it in other missions or other tasks. You can also test the trained model using the same technique as above, by using the fast language model and for inference, and then the model itself, and then what is the question that you want it to answer. In my case now, it's much better because, as you can see below, here's an instruction that describes the task, write a response that properly completes the request. The question is, write me a good example of procurement and tender level 2. The answer, instead of not providing anything on local authority, there was 2-stage design and build, open book tender process. So yeah, it's quite relevant. And then you can now save the model itself locally on your machine. It's quite straightforward. You just need to type in model.save_pretrained_gguf, and then the name of the folder where you want the model to be saved, and then tokenizer. Here you can also add another argument for the quantization. It could also be 4-bit, 5-bit, 6-bit, or 8-bit or 16-bit if you want the full-sized one. And I'll show you here on the left. If you could see Gemma 2 on the left, you'll find that it saved 4 files as safe tensors. These are the main model itself, and then compressed them or quantize them into 8-bit here. The size of the whole folder is exceeding 20 something gigabytes, because that one alone is 9 gigabytes, the model itself, and then four files are about 16-17 gigabytes, so the whole thing is about 25 to 27 gigabytes. So you have to be aware of that. These 4 safe tensor files that you can't really be used in chatbots, the one which can be used in chatbot is the GGUF one, so you have to keep that in mind as well. Having fine-tuned the large language model, or the range of the large language models on your preferred dataset, it's now time to deploy them in a chatbot. So instead of creating a chatbot from scratch, there is an initiative on GitHub called Open WebUI, which stands for Open Web User Interface. And it really stands out. So you can access it by going to the github.com website /open-webui/open-webui. And then you'll see here that it contains all of them folders and files that helped in creating this amazing initiative. If you scroll down a bit, you'll see what it is capable of. It resembles a little bit ChatGPT in its interface. Here you'll find all of them key features and a thorough and detailed description about the functionalities of this initiative. The way to install it on your PC, regardless whether you're using Linux or Windows, is going to be the same. It's going to be through terminal. You can install OpenWebUI using two methods. If you have Llama already on your computer, what you can do is you can use that line of code if you just want to have the CPU version only. If you have the GPU version, then use that line of code here and put it in your terminal. In my case, what worked for me is installing OpenWebUI bundled Llama support, and I do have a GPU, so I use this line of code. If you don't have a GPU, you can use this line of code. It's quite straightforward. You just need to copy it and then open a terminal window, and then what you can do is you can say sudo to give you root privileges and permissions, and then copy the code itself. For me, in order to make it easy for me in terms of the naming, I scrolled using the left arrow key until Open-WebUI after the name feature, and I called it Llama-GPU, and then I pressed enter. I have already done it. It's going to download about 3 gigabytes, more or less 3 gigabytes of data. Once you do that, you can check the image itself, which is installed on Docker using sudo and then docker and then ps-a. It's going to ask you for your password because sudo again gives you root permissions. So I'm going to type in my password. So I do possess 2 images, as you could see here, and this line of code on the terminal, or this command, it allows me to understand what images I do possess and some features and statistics about them. So as you can see here, I have the Llama one and the CUDA one. That one, unfortunately, it was not loading any sort of GGF models. I'm not sure why. That one, it loaded. So that's the name that is saved on the system. In order to activate this image, you type sudo docker and then start for starting the session, and then the name of the image. On Windows, it's going to be completely different because you'll have Docker Desktop on Windows. Unfortunately for me here in Linux, I'm not sure why it didn't work perfectly fine for me, but on Windows you're going to have the images here, and then you'll have to press start only. So that's the way it worked for me on Linux. Whenever you've finished with your work, you can stop the image itself or stop the container using sudo docker stop and then the name of the image or the name of the container that you do have or you do possess. And then in order to open the container that you have enabled or started, you'll have to type in local host and then semicolon 3000 and then press enter. For me, I've already opened it here. So you're gonna have to provide a username and a password. I'm not sure why they'd have done that. It's not connected to the internet in any way, shape or form. It's completely local, but you're gonna have to type in your username and a password. You're going to be greeted with something that's quite empty here. I've created a couple of them chats in order to showcase what I've done. But normally you wouldn't have any models, you wouldn't have anything at all. You wouldn't have any models here, you wouldn't have any chats. This is going to be completely black. So in order to add your first models, you can go to the name of your account, go to admin panel, and then go to settings, and then go to models. And here begins the fun part. The last bit here, which is experimental, click on show on the right. And then you can upload the fine-tuned GGF model that we have done using Unsloth. So click here to select, and then select your preferred model, double click on it, and then press on the upload button, which is going to be uploading it locally inside OpenWebUI so that we can use it further. I have done that. If you go to workspace on the top left, I have already done that 3 times. Inside each and every single model that you do possess, you can press on the edit, and then here you can play around with a multitude of settings. So first thing is you can edit the name of the model, you can have some sort of description. I have added custom prompt to make it more defined and provide some sort of more standardized responses. There are also a plethora of advanced parameters, including the top P and top K and temperature. I played around with the temperature to make it as less as possible so that it provides quite concise answers. Also, you can add documents which are going to be used as knowledge bases for the model itself. You can select whatever documents you want. The documents can be uploaded if you go to documents here, and then you can press on the plus icon, and then you can select whatever documents you want. In my case, I've already fine-tuned the model, so it contains all of the knowledge inside of it. I don't need to add in knowledge documents, at least in this period of time. So going back to these models, once you have finished all what you want to do, you press save and update. You can also add lots of tools, actions, functions by accessing these other tabs. If you want to add a tool, you have to go to the OpenWebUI community and you have to play around with it in order to understand how you can build a tool inside OpenWebUI. And then it's like ChatGPT. You go inside any chat and then you can choose whatever model you want and ask a question. There are 3 main shortcuts that anybody who is using OpenWebUI should be aware of. The first one is @ which chooses the model. It acts like agents. The second one is hashtag, which is for documents, if you have documents uploaded. The third one is the /, which is for systematic prompts that you have created. So you can go to workspace and then you can have prompts, create a new prompt, and then as you could see here, there is a /. So you can add, if you want to have, as it says here, write a summary in 50 words that summarizes a specific topic or whatever it is, or you can play around with the prompts however you see fit. If you just press the / and then the short summary or the short name of your prompt. Now going to the main juicy part, which is comparison of the 3 models that I have fine-tuned: Mistral version 0.3, Llama 3.1 Instruct, and Gemma 2 9 billion parameter model. Them 3 models, they are quite close. Mistral is 7 billion parameter, Llama is 8 billion parameter, and Gemma is 9 billion parameter. So they're all nearly on par with one another. So which one is best in my case using the Unsloth method? So I began with asking some questions about procurement and tendering, and then I jumped to risk management, and then I finished the race with a question about contract practice. So the first question, it's the same question across the board for all of the 3 models. What is a good quality example for procurement and tendering level 2? Llama 3, it provided a very concise response, and for me, I think you might need a bit more when you are drafting your submission. So it's either you can expand manually on this, or you can have an option of generating another response. Gemma 9 billion parameter, if you could see here, it's an identical response. So these 2, they were on par in this question. Mistral, it provided another example. It's all the same dataset, which is composed of 331 rows of data. Mistral provided another response, which I think it was more relevant in this case. Instead of just faffing about with the procurement process itself, it's the actual interview and the scoring method. So I think Mistral in this case is going to be the clear winner in this specific area. The speed of the 3 of them is nearly the same because the sizes of them is nearly the same. However, Mistral has this kind of potential of faffing a lot, which I'm going to showcase in a bit. So sometimes it might not be the clear winner. Risk management, Llama 3, which is the one on top, it provided a very short response, which is too short for my liking. So it's either you do multiple prompts or you try to ask the model to expand. So it had made 2 responses. Both of them are relevant, but they are quite short. So there might be a potential to generate multiple responses and then stack them on top of one another. and tried to tweak them a little bit in order to make it easier for the reader or for the RICS assessor. The same happened with Gemma. It was quite short, quite concise, which is too short for my liking, so I think it might be worthy to have two responses stacked on one another in order to provide a richer context for the end user. Mistral, again, having the potential to be the best model in this case, but it's stretched out a lot and it faffed a lot about risk management, covering a wide variety of them areas which might not be quite relevant. So it covered a part about the contractor's payment, which is not related to risk management in this case, reviewing program, so that is not quite relevant. It faffed a lot, so it produced some decent bits and pieces, at least in these 2 paragraphs, but then the remaining was just a bit of a faff really. So it provided a richer context, but it did not follow the instructions word for word, although there was a custom prompt or a system prompt provided for all of them 3 models. It was exactly the same system prompt for all of them 3 models. And the last area is contract practice, and from what I've seen, Llama has this kind of consistent approach to responses, short and concise. Short and concise, it can work, don't get me wrong, but I think multiple responses need to be staggered on top of one another. It's quite relevant, it's within the context, but it needs to be richer. So there is a way of stacking multiple responses on top of one another, or expanding on each and every single response. Gemma 2, I think for this area, I think it was the best fit. It provided 3 examples in my preferred amount of words. So I would say that Gemma 2, a 9-bit parameter, the bits and bytes 4-bit is the clear winner in this specific chat. Again, Mistral, it faffed a lot. It's within the context, but it faffed a lot. So when you have this response, most likely you're going to have to summarize it a bit in order to fit within the RICS APC submission. So I think Gemma 3 is the clear winner in this chat. And here comes the final part, which is the comparison of all of them 3 models after seeing them and after deploying them in OpenWebUI. So I'll be relying on 3 criteria for comparison. The first one is speed, the second one is precision, the third one is convenience. So for the speed, they're all on par because they're all in the range of 7 to 9 billion parameter models, so there isn't really a lot of difference between all of them. So for the speed, they're all equal. They were all quite fast to respond. For the second criteria, which is the precision, Llama 3 is quite precise. Gemma is on par with Llama 3. However, Mistral sometimes faffs a lot to the extent that the response might come as inaccurate. This means that in the case of Mistral, you're going to have to do some sort of cutting down the response in order to suit your needs. And then the third is convenience. Convenience, the way I see it, is how convenient the response is for you and for your use case, for your style of writing and the likes. Llama 3 is too short. I know that it's precise, but it's too short for my liking. That means that I'm going to have to expand. Gemma, I think it provides a middle ground between Llama and Mistral in this case. Mistral provides a very lengthy answer, which might be useful for some people, it might be not useful for others. In my case, I think I'm going to be going forward with Gemma as the overall winner in this comparison. Thanks a lot for watching. Hope you found this video useful and insightful. I've prepared a couple of them other videos about fine-tuning large language models and deploying them to OpenWebUI. I'm going to be putting the links in the description below. You can also pay my website a visit at www.apcmasterypath.co.uk, where I provide multiple packages for the RICS APC candidates to support them throughout their RICS journey. Also, I provide lots of insights about the RICS APC process, the different areas of competence, and how you can deploy AI within the construction industry. Do not forget to hit the like button and subscribe so that you get notified about our latest videos.